the title has actually been polynomials. And that's because the focus of this unit isn't actually exponents. Well, we need to understand exponents and how they work. It isn't our overall focus. Our overall focus is going to be polynomials. So some English in here we need to do. What does the prefix poly mean?
Many.
Many. So when we are talking about polynomials, we're actually talking about something with many terms. Okay, and we could write down a fancy book definition, but a term is just each individual piece that is being added or subtracted from each other. So if we have something like 3x squared plus 7x minus 4. Okay, we would say that this is a type of polynomial because it has terms being added and subtracted from each other. Okay, so we have one term. This is our first term.
And the second term would be 7.
We have our second term. And we have our third term. So we would say that this is a polynomial that has 3 terms.
So wouldn't it be 10x?
We can't add or subtract or do anything with them because they're not like terms. So we're going to talk a little bit more about that in specifics. But, okay, the vocabulary that we need to take a closer look at is once we know how many terms it has, it then gets its own little fancy name. And while there are lots of different fancy names, and we're not going to focus on all of them, we are going to focus on a few of them. All right, so here are the terms we need to know. When there is only one piece, which is what we have been looking at basically for the last week, when we don't see anything being added or subtracted, when there is only one term, the fancy word that this gets is a monomial. And what does the prefix in the English language mono mean? One. Well, so my morning class said the same thing, mononucleosis. You should actually do some reading on. Mono is really called mononucleosis. And the reason why is because scientifically there's some piece with it being like one cell or only having one something, and it's something attached to one. Okay, if there are 2 terms, anybody know what prefix is 2?
By, yes.
It's like a bicycle. It is a binomial.
Trinomial was next on that.
And if it has 3 terms, it is a trinomial. Now, there's all types of words and labels we could give. We're pretty much going to function in the worlds of monomials, binomials, and trinomials. Or we'll just say, okay, it has 5 terms. It has 7 terms. I mean, I'm just making up, like, we're not going to give it a fancy name. Right, there was probably at some point at a younger level that you were like learning about dodecagons and all the fancy names, but at this point you're kind of like, okay, it has 12 sides.
Isn't that like
A dodecagon and a decagon, a heptagon, a septagon,
Hexagon.
are the same thing.
that's like a Yu-Gi-Oh thing.
No. Okay, the other thing that we can talk about with polynomials is we can talk about the degree of the polynomial. And this terminology isn't necessarily super important this unit, but it really actually is important as we move on because it tells us characteristics about the polynomial. And you actually know some of these terms. We've been using them. We just haven't attached it to the degree yet. I didn't use that word at the time. Okay, so to find the degree, we are going to take the sum of the variable's exponents of each term. Okay, and then from those, we are going to use the largest.
You should use the largest. Why would we want to use the largest?
Because it actually determines the properties and characteristics of it.
Okay.
It has more sort of pull than the rest of it does. Anything smaller just gets sort of,
Pushed away.
yeah.
Okay.
That larger exponent's going to have the pull. Now, one piece that's important to understand is that we can have multiple variables, but still only be talking about one term. So we said that a term are things being added or subtracted from each other. So if I say something like x squared y to the third, this is still only one term because there's no addition or subtraction.
Wait, use the longest what?
Use the largest.
Oh, the largest.
You said x squared and y third is still 1.
There's pencils up there. I'm looking at if you need some. Okay, so since this is only one term, we are going to find the sum of the variable's exponents. So what does sum tell us to do? Add. So what is 2 plus 3?
5.
5. So we would say that this has a degree of 5.
So we don't solve it, it's just
Right, this is not solving. This is sort of like just giving it some characteristics.
so like
Right, you wear glasses, you have brown hair, right? Those are things that are identifiers that maybe tell us more about this polynomial.
So it's basically making it important. So like a title.
Yeah.
Okay.
Okay, so what if I say 4x to the third plus 5x? How many terms does that have? 2. So what would we call this in terms of naming it by its number of terms?
Oh, binomial.
A binomial. This is a binomial. And so we are going to look at each term and we are going to add up the exponents on variables. So I'm going to look at the first term. Is the 4 a variable?
No.
Nope, so it doesn't count. It has an exponent, but it doesn't count. So the only thing that we can count is just that 3. There isn't even really anything to add it with because there's only 1 there. All right, what would we say is the sum of the exponents for 5x? 1, because there's nothing else there to add it with. And then we are going to use the largest. So what's larger, 3 or 1? 3. So we would say that this has a degree of 3.
So we wouldn't add those exponents at this point in time?
Correct, because they're different terms.
Okay.
Now these get fancy words too. Okay, so a degree of 3 is also called cubic.
Oh yeah, I remember that.
Okay, and it will have certain properties about it because it is cubic.
Squared, no, cube, that's different.
This is a
5x squared plus This is a binomial. That's not really important. What is the degree on this first term? 2. What is the degree on this 7?
Uh-oh.
Or 0.
0, because there's nothing,
So-
right?
So we would have to pick 2 or what?
Pick the larger, which is 2. So this has a degree of 2
Wait, how is it 0?
because there's no, it only has to be on a variable. And since there's no variable,
There's no variable.
it's a 0.
We would say it would equal 1, right?
What?
Oh no, my bad. I'm thinking of the other.
Okay, a degree of 2 is called quadratic. So here's your Teach Mrs. McKinney extra credit of the day. Okay, if you go home and you research and you come back and you report back to me, why is a quadratic called a degree of 2? Why is that weird? Why does that not seem normal?
Because quad means 4.
Quad means 4. So why do we pick it for a degree of 2?
Because 2 plus 2 is 4.
Go home and research it. You have to come back with evidence. Tell me why we call a quadratic a degree of 2.
Do we get any?
Other than my reasoning, which is I blame old men.
Wait, what do we get?
It's extra credit.
How much?
I think I have it labeled in there as 5 points.
How about 5%?
No.
What? No, don't push it, man. Just be happy with it. Good.
I would actually get 5%.
7y.
Would it be 1?
So this is a monomial,
Yeah, mom.
and all we have is the 1 there, right? Is up here, please.
Sorry. Alright.
So this has a degree of 1. Don't go right back to the conversation. A degree of 1 we call linear.
This kind of makes sense, but the words.
Right, so we should start going, wait, these are words I've heard before too. Right, we've done graphing linear functions. Linear functions always look like a line. So when we know something has a degree of 1, we know its graph should look like a line. Quadratics are always a degree of 2. We sort of have talked about this, but we know quadratics are that U shape. We'll do more with that later.
U or V?
A U, absolute value are the V's.
Okay.
Yes, Sutton?
Remind me why we added the exponents on the first one?
Because there's no adding or subtracting in between it.
Okay.
It's only one term.
Is that a 1 underneath the y?
Yep. So this is a term I use all the time, so I don't know if we need to write it, but if I say 4, what does this have a degree of?
1.
0.
0.
Oh, wait.
Oh.
But something with a degree of 0, what's the word I use for it?
Those?
Quad.
Dose.
Quadratic, right?
Gosh.
Maybe I do need to write it.
Constant.
It's our constant, right? Do we at least say, oh yeah, I've heard Mrs. McKinney say that word a lot?
I remember now.
Oh, okay. Okay, great. So we have all of this information and we have these terms. Okay, this isn't something that you're going to go home and like have a test over this, or I'm going to give you an assignment where you just label 100 of them. It's vocabulary that we will be using regularly. So I want you to just like recognize and know what that vocabulary means as we go forward.
Yes, ma'am.
Are we okay on that?
Yes.
Ma'am.
Then the other piece that we are adding today is, okay, now that we know about these polynomials, what can we do with them? And we are basically going to redo everything that we've done this week, but now instead of it being adding and subtracting a monomial plus a monomial, we want to be able to add and subtract a polynomial plus a polynomial. So now instead of one little thing plus one little thing, we want one big thing plus one big thing.
So are we in the big equations?
Nope, no equations yet. We're still just simplifying. No solving. The good news is is that there realistically isn't much new information. Because we already know the property says when we add and subtract with exponents, we can only add if their base and exponent match. And when we add them, we keep the exponent the same. So all we're really doing, guys, is combining like terms. We're getting like terms together. And that's something we know how to do. We've been doing that just fine.
So it'd be 9x.
So it's just a super fancy combining like terms. So we're going to sort of treat this like we did systems. And we're going to go down each column because these are nice and neatly stacked for us. So a 4x squared plus a 5x squared is going to give us a what?
9.
9x
For the 4. Oh, to the second.
squared, because when we add, we keep exponents the same. And a 6x plus a negative 9x gives us
Negative 4.
negative 3x.
And that'd be 6.
And no, because we have two negatives. So a negative 8 plus a negative 2 gives us a,
Negative 10.
and that's our answer?
That was easy.
No.
Yeah, that's our answer.
Oh yeah.
Because there's no solving, there's nothing else we can combine.
That was,
Now, we say this answer and how it is written in standard form. And at this point, my students are like, Mrs. McKinney, you have told me standard form like 14 times this trimester. And you're right. I also blame old dead men. I don't know. Standard form is less of a specific definition, right? Standard form last unit was ax plus by equals c.
yeah. So there's different forms. of-
Standard form is sort of the agreed upon way to write something based in what situation we're in. And it is agreed upon that when we are working with polynomials, we will write this from largest exponent to smallest exponent. Okay, and so we always need our answers to be in standard form. Otherwise, we could all have our terms shuffled in a different order. I mean, if we had 100 terms, there'd be so many different ways we could write that answer, and it's then hard to compare and see if we all agree. And that's one thing we want to be able to do in the math world. If we're trying to show something, we want to actually show that not only do I think this is the case, but other people are agreeing with that math as well.
Behind you. It's on you.
Oh, she's so pleased.
Is he just staring at you?
So let's look at another one. 6y to the 4th minus 8y squared plus 7. And we are going to subtract 3y to the 4th minus 5y plus 2. Okay, so this is going to sound really familiar. My students don't have problems with polynomials and exponents. My students can't subtract. We mess up subtraction all the time. Not only that we just make mistakes and errors, but polynomials open the door for there to be some weird things that happen with subtraction. So remember when we were talking about elimination? And instead of subtracting, what did we actually do? How did we, yep, we added the opposite. We multiplied by that negative 1 because we didn't want to actually have to subtract. So we are going to use that same idea here. Okay, so if you are still holding on tight to the, well, I'm just going to subtract and I'm going to subtract fine, I'm telling you it will come and bite you in the butt. Change subtraction to addition. Add the opposite. It literally takes like a second. You will change this to a positive. And then you change the sign of everything that follows it. Not before it, But what follows it? So if this was a positive 3, it becomes a negative 3. If this was a negative 5, it becomes a positive 5.
And then the 2 would be.
A positive 2 becomes a negative 2.
So negative 9y. Did I do that right?
No, because this will be a negative 3.
Oh, so you only change the bottom one?
Yes, because that's what follows it.
So negative 3y.
Positive 3.
Crap.
So we'll have 3y to the what?
4th.
Then what?
Negative 3.
Oh, this should have a 2 on it, guys. I just wrote it down wrong. Put a 2 on that second one. Sorry. We're going to talk about that piece next. But so minus 3y
To the second.
squared plus 5. Excellent. Right, so once we change that into addition, then we're just still adding straight down, combining like terms, no problem. Now, unfortunately, everything doesn't always work out nice and neat that we can like write it in this nice stacked format. Because sometimes they just don't have the same amount of terms. And so sometimes we get something that looks like this.
Or where it's offset.
It's just all random.
Wait, can you go back to the other?
Go back to
The second one was in parentheses.
Okay. Okay, so let's say we have 3x plus 4x squared minus 6 minus 5 minus 3x to the third plus 7x.
Can't you bring that down to the bottom? Can you bring that
Now, we can't bring it over and stack it because if we did bring this over and stack it, they don't match up. We don't have ones to necessarily line them up with. Okay, that doesn't mean we want to do everything completely different. We should still look at this and notice that there's subtraction. So when there is subtraction, what do we want to change this to? Addition, and then change the sign of everything that follows it. So a positive 5 becomes a negative 5,
3,
positive 3, negative 7. And now actually we're just going to sort of think about this like we're simplifying one side of an equation and we're just getting like terms together. But we're going to try and be very strategic with how we get those like terms together. Because we could just randomly get them together. But remember we said we also wanted the largest exponent first.
Can you combine like terms for the sevens?
So we're going to start, I think it's easiest to start with the largest exponent that we see.
3.
So 3 is the largest exponent that we see. Is there anything else that has an exponent of 3? Nope, so there's nothing else that we can combine it with. So this 3x to the third is just coming down. What's the next largest exponent that we see?
4x.
2. Anything that we can combine that has an exponent of 2? Nope, so this just comes down. Next largest exponent that we see? 1.
Oh yeah.
Anything that we can combine with a 3x?
7.
So my students at this point are like, oh, this is kind of annoying. Yeah, this is a little bit tedious. It's not difficult, it's just a little bit annoying. Okay, so what is a 3x plus a negative 7x?
Negative 4.
Because we changed it to adding the opposite. And then what's the last thing we have to do?
0, so 1. Right, it'd be 1.
Yep, so a negative 6 and a then negative 5 is a,
1, 2. Then wait.
because they're both negative. If you borrow 6 and then you borrow 5, you've borrowed 11.
Oh, yeah.